Hello everyone, I am Dr. K. Maniyandan, working as an assistant professor in the Department of Physics, Kamaraj College of Engineering and Technology, Virudhunagar. In this video, we are going to discuss an interesting topic in thermal physics, heat exchanger, and it's one of the application, refrigerator. Let's first discuss the heat exchanger and its various types and its application. What are heat exchangers? So heat exchangers is a device that transfer heat between two or more fluid at a different temperature without direct mixing. First characteristics of heat exchanger is flow configuration. Flow configuration simply refers to the arrangement provided within the heat exchanger. Based on the flow configuration, there are four types of flow configuration. First one is parallel flow heat exchanger. Second one is counter flow heat exchanger. Third one is cross flow heat exchanger. Fourth one is hybrid flow heat exchanger. Let's see the first type of flow configuration, parallel flow heat exchanger. In the parallel flow heat exchanger, two fluids enter the heat exchanger at the same end and travel in parallel to each other and reaches the other end. So this is a schematic representation of a heat exchanger. So this is one type of a shell and tube heat exchanger. This is a tube and this one is shell. The one type of liquid flowing through the tube and another type of fluid flowing through the shell. The inlet for first fluid, that is a cold in nature. The outlet for first fluid is hot. So this is the outlet for first fluid. Then inlet for second fluid hot in state and outlet for second fluid is cold. So this way of heat energy exchange between one fluid to another, and also the direction of heat flow, both are in parallel with each other and same direction. Such type of flow heat exchangers are parallel flow heat exchanger. This is a counter flow heat exchanger. Counter flow heat exchanger are designed such that the fluids move anti-parallel, parallel but opposite direction to each other within the heat exchanger. So the schematic representation of counter flow heat exchanger, the direction of fluids both are opposite with each other and parallel. This type of heat exchangers are counter flow heat exchanger. So next type of heat exchanger, cross flow heat exchanger. So in the cross flow heat exchangers, fluid flow perpendicularly to each other. So schematic representation of cross flow heat exchanger. So in this cross flow heat exchanger, so it consists of, there are two types of fluid. So inlet for first fluid cold and outlet for first fluid hot in nature. So this is the position of inlet and outlet of cross flow heat exchanger, the direction of the fluid flow. So both are perpendicular with each other. Such type of heat exchangers are cross flow heat exchanger. Fourth type of heat exchangers are hybrid flow heat exchanger. It is a combination of any type of parallel or counter flow heat exchanger and cross flow heat exchanger. So this is a schematic representation of hybrid flow heat exchanger. So now it consists of counter flow or parallel flow heat exchanger and also cross flow heat exchanger. So this way of exchange the heat between one liquid to another liquid, such type of heat exchangers is called a hybrid flow heat exchanger. So classification of heat exchanger based on heat transfer mechanism. So there are two types of heat transfer mechanism. First one is direct contact type heat exchanger and another one is indirect contact heat exchanger. So in the direct contact heat exchanger does not contain any wall tube. So it is a direct mixing of fluid with each other. Second type of heat transfer mechanism is indirect contact type heat exchanger. This type involves the heat exchange between hot and cold fluid across a construction wall. The separating wall is used generally tube, pipe or vessel. For example, shell and tube method, so plate type heat exchangers. Let's see the classification of heat exchanger based on construction. So there are 5 types of heat exchanger based on the construction. First one is shell and tube type heat exchanger. Second one is plate heat exchanger. Third one is helical heat exchanger. Fourth one is double tube heat exchanger. Last one is spiral heat exchanger. Let's see the application of heat exchanger. So these are the important applications of heat exchangers. First one, condensers and boilers in steam plant, condensers and evaporators in refrigeration unit, automobile radiator, oil coolers of heat engine, milk chiller of pasteurizing plant, petroleum refineries, petrochemical plants. These are all about the heat exchangers. Let's explore another important topic, refrigerator. Refrigerator is an important and integral part of household. What is a refrigerator? Refrigerator is a device used to reduce and maintain the temperature below the atmospheric temperature. The types of refrigerator, there are two types of refrigerator. First one is vapor compression refrigerator. It is a domestic refrigerator. Next one is vapor absorption refrigerator. It is known as commercial refrigerator. In this video, we will focus on domestic refrigerator, vapor compression refrigerator. The basic principle of refrigeration is the second law of thermodynamics. According to the Clausius statement, without doing external work, it is impossible to transfer heat from cold body to hot body. Let's see the different components and working of refrigerator. First one is refrigerant. Refrigerant is a substance or mixture usually in the form of fluid or gas that is used in a refrigeration cycle to absorb heat from one place to and it released to another place. The examples of refrigerant are 134A, tetrafluoroethane, widely used in car ACs and domestic refrigeration, or 410A, used in modern air conditioning system, ammonia R717, used in industrial refrigeration, CO2, carbon dioxide based refrigerant R744, an eco-friendly refrigerant gaining popularity. Main parts of refrigerator: expansion valve, evaporator, compressor and condenser. First component is expansion valve. So this is an expansion valve, control the flow of the liquid refrigerant and sensitive to temperature changes of the refrigerant. In addition to, this is an inlet of expansion valve and this is an outlet of expansion valve. So inlet we are allowing refrigerant that is in liquid form at a high pressure around 8 bar. The temperature is around 45 degrees Celsius. Then liquid refrigerant flowing through the expansion valve and reached to another end. The length of the expansion valve is around 2 meter and the diameter is very small, 0.6 millimeter. The sudden drop in pressure, the low pressure is maintained at the another end. The pressure is around 0.6 bar and liquid form. The temperature is around minus 20 degree Celsius. Another component of refrigerator is evaporator. So this is an evaporator. So this evaporator is located inside the refrigerator. It is a finned tube with a high thermal conductivity and the evaporator absorbs heat from the food substance. The refrigerant turns into vapor. So this is a function of evaporator. So next component, condenser. So condenser is located at the back side of the refrigerator. The set of tubes with external fins and located at the back side of the refrigerator. So condenser and evaporator is a one type of heat exchanger. So the condenser, it liquefies the gaseous refrigerant by absorbing its heat and expel it to its surroundings. So this is a schematic representation of the vapor compression refrigeration cycle. So it consists of important parts: expansion valve, evaporator, compressor and condenser. So this expansion valve carry the refrigerant, so initially in the liquid form, and it reached to the another end. It is also liquid form but low pressure is maintained. That low pressure cold liquid flowing through the evaporator, and the evaporator role is absorb the heat from the food substance inside the refrigerator. Then that low pressure cold liquid become a cool low pressure gas. The liquid is converted into gaseous form or vapor form. Then we need a cyclic process, so that's why the low pressure is converted into high pressure by applying external work. So that's why we introduce one electronic device, that is a compressor. The cool low pressure gas is reached to the another end of the evaporator, then the cool low pressure gas enter into the compressor. Compressor convert low pressure gas into high pressure gas and a higher temperature. That hot high pressure gas flowing through the condenser coil, that condenser coil is a one type of heat exchanger which is located at the back side of the refrigerator, which dissipate the heat energy to its surroundings. The inlet of the condenser coil, the temperature is very high, around 90 degrees Celsius. After the heat dissipation process, then another end of the condenser coil, so here the normal temperature is maintained and also the hot high pressure gas is converted into warm high pressure liquid form. So that high pressure liquid again enter into the expansion valve. So now the process is keep on repeating, so we will get a continuous cooling effect. So these are all about the working of the vapor compression refrigeration cycle. Let's see the one important term, the coefficient of performance. So this term which is used to evaluate the performance of a refrigerator. The output is evaluated by the heat absorption process, then input is evaluated by the power input. The coefficient of performance equal to heat absorbed divided by power input. Let's see the advantages and disadvantages of refrigerator. First one is advantages. It is used to store food for a long time. It protects the food from microbes and insects. It protects the food from the direct sunlight and heat. Cost of refrigerant is low. Next, disadvantages of refrigerator. It consumes large amount of electricity. It causes global warming. Preserving food in refrigerator for a long duration is not good for health. These are all the applications of refrigerator. It is used for preserving the food, fruits and drinks for a long duration. It is used to preserve flowers, medicines and medical drug. Refrigerator is used to manufacturing ice in ice plant. It is used for producing frozen foods, ice creams and chemicals. Thank you.